Welcome everyone to the first AM Chronicle Middle East Outreach webinar, where the focus with these webinars is to uh, look at different applications sectors of additive manufacturing, look at the challenges and opportunities in these, and see how we can, spread the right awareness and look at detailing some of the applications and opportunities in this space. So, welcome once again. And today's session is focused on the polymer AM opportunities in oil and gas, powered by Markforged and Phillips machine tools. Where we're focusing on the opportunities and challenges in the polymer AM opportunities, let's say in the oil and gas sector. And what we've seen in the past few years is that additive manufacturing has moved from a prototyping technology for various applications to slowly moving into applications which are more manufacturing focused. Let's say look at the potential use of additive manufacturing in spare manufacturing, potential use in manufacturing components. So, and oil and gas, of course, is one of the largest industries today worldwide in terms of market cap. So, we thought let's start this outreach with the opportunities additive manufacturing provides to the oil and gas industry. So, we have a panel of speakers today who bring diverse expertise across the table. So, we have Kyle Mason, who is a territory sales manager, Middle East and Africa for Markforged. We have Dr. Sastry Kandukuri, who is the global practice lead additive manufacturing at BNV. And we have Tirtha Sarma, who is the business development manager at Falcon Technologies International, Russell Khaimah. So they bring diverse expertise, one from the technology side, Tirtha from the application and the oil and gas expertise side, and Dr. Sastry from the qualification and standards and safety side. So it allows us to give a well-rounded picture to the audience today. So with this, I'll just share what we're doing today in this session. So we will have two presentations, one from Mr. Tirtha Kumar from Sarma, and who is going to talk about the opportunities in oil and gas, and followed by a presentation by Kyle Mason on the few case studies and applications of polymer AM in oil and gas. And then we will move into a panel where Dr. Sastry will join us as well to share his insights. So with this, I'd like to invite Mr. Tirtha Sarma for his presentation.
Thank you, Aditya, and thank you, Kyle, and also Dr. Sastry for being here and sharing their platform today. My name is Tirtha Sarma. I'm the business development manager looking after the additive manufacturing division in Falcon Technologies International, which is based in Russell Khaimah, UAE. And this division in Falcon Technologies has been for now last couple of years. It has been a successful story here, slowly kind of developing. But before talking about my company and others, I would like to highlight my background, which is a bit on the other side of the additive manufacturing, which is quite conventional. I come from around 10 years of experience in the Middle East. For last 10 years, I was here in different companies serving the oil and gas industry in different field services, in metallics and non-metallics kind of solutions, mostly working around ADNOC and Aramco ecosystem. And which is, which has given me kind of an exposure to the application side where the additive manufacturing can be used, and that's why probably I'm here. And now I'd like to share my screen for a brief presentation and about what I will mostly talk about challenges we are facing at this moment in this oil and gas industry, or taking up in new challenges, and I'll also briefly talk about my company, what we are doing there. I'm sharing the screen. Coming back to the oil and gas industry, it is as it has been, being prophesied for last couple of decades that oil industry is getting diminished very soon. The peak oil is here, and it is going to be, and for the whole industry itself, I do not see, or we the industry people do not see it happening very quickly. For the next couple of decades, it's going to stay here, but it has developed the kind of tendency or the intention now to take the responsibility of decarbonization, or it has taken up the green responsibilities, which is eminent for the entire world. And in this effort, the decision makers across the oil companies have taken different levels of policy decisions to embark on greener solutions, where additive manufacturing is probably one of the cog in the wheel, which provides quite a kind of greener solution than conventional ones, if it can be applied on the right for the right solutions. And in the oil and gas industry, being a highly technology intensive industry, it has always big appetite for new technologies, innovation and optimization. Already we have seen how the automation has taken place, which was part of Industry 3.0, and it has taken the whole industries, including oil and gas industry, by storm already. Now the time has come for Industry 4.0, and where the additive manufacturing or 3D printing in the commercial sense will play the biggest role. But at the same time, there's a risk aversion kind of tendency in the oil and gas industry people, because there's extensive risk involved in across the the ecosystem. The risk of health, safety, and environment is there. So that how to surpass this risk involved in the inherently involved in the system is a key challenge. And in the last couple of years, there is a tendency of the decision makers in the oil and gas companies, primarily the one from the Middle East. We have seen ADNOC, and it's led even by further by Aramco. It's in its importance towards non-metallics. It has already extensively used, Aramco particularly has used a lot, extensively used non-metallics in its piping systems in other applications as well. And where we are talking about the polymer AM applications today. So I believe that this is kind of there's a synergy happening, can happen there. And overall, you have seen in the last decade, since 2014 onwards, or I will say drawing from the 2008 the kind of economic slowdown, etc., and which was enhanced in 2014 onwards, we have seen a low cost environment. The price, the crude oil price, that time it went down steeply, and it is back again under the higher price, but still the volatility is extreme. So the decision makers have taken mostly the route for low cost environment, and this is where a smarter supply chain can play a big role. Now we'll talk about why a supply chain needs to be smarter, and we'll also talk about what are the opportunities available for non-metallics or polymers in the oil and gas system. If we see in summary, or from outside, we'll always see the big pipelines, which are steel pipelines and big equipments in steel, etc. But in a sense, nowadays, you will see kilometers of kilometers non-metallic pipelines are being set up by Aramco and also ADNOC. While I was working with the Aramco's non-metallic program, I have come across a very beautiful document from them. I would like to share a part of that. Why non-metallics is part of their core agenda. And this is the first one is to eliminate corrosion. Corrosion itself is $1 trillion problem for the entire world, including which is predominant in the oil and gas industry, and generate revenue and job opportunities. These countries, these Middle East countries, now they're seeing a diversion of their, the resources. End use is being diverted from the end use fuels to non-conventional technology, the fuel and kind of energy technology is taking place. So which actually gives a different, alternative source for diverting the products. And that's where the petrochemical sector comes up. So this is expected, and the importance Aramco has given on Sabic's expansion, ADNOC has given on Barouge expansion, and its even recent IPOs and etc. We can see the importance the regional oil companies have put on that. Minimize the life cycle cost. That's very important. Even if we see quickly, the cost might be higher of a high performance polymer than other things, but in the overall scenario of the life cycle of the project, it minimizes the cost and maximizes the value of the resources by converting oil into high value products. So where I have already talked about this generation of the economic values is also linked with this maximization point, and reduce the carbon footprint overall, which is obviously the case, because the more the metals are being used, the amount of carbonization increases, and use of non-metallics actually decreases the carbonization component. This is a very important point I'd like to highlight here, is that Aramco has the non-metallic polymer application on the onshore, offshore platforms. Downhole applications are also there in plant rehabilitation projects, and deploying various projects such as RTP pipes is a big project for Aramco. And they're also using it in their downhole line tubulars, non-metallic compression tools, and even valve bodies, etc., are being manufactured with a high performance peak and etc. Recently, TWI and Aramco and ADNOC has started a non-metallic innovation center in UK, and that is trying to walk further walks towards innovation and different product applications of non-metallic products. And advent of super polymers, which is one of his peak, is very important, and the carbon peak is another, and other composites are also being developed across the world, and these are finding lot applications, and particularly the kind of the temperature and pressure resistance these new materials are showing, it is very prominent, and it's very impressive for the oil and gas industry. I talked about this earlier, that a supply chain needs to be smarter nowadays in the low cost environment for the oil and gas industry. And if we talk about it, why a supply chain needs to be smarter, this small picture of the large vessel shows why it should be like. It was a small incident in the Suez Canal, where we see that the whole supply chain from Europe towards the Asian side, Asian markets was stuck for almost a week or more, and how we suffered. And we are still seeing how the thousands of ships are still getting stuck near Shanghai and those areas post-COVID scenario. And this has actually given a thing to new point of view to think about, is why we should localize the manufacturing, or not entirely depend on one part of the world or something like that, just for entire supply chain. So this is, we believe, is kind of a post-globalization scenario is happening, and this is giving a new fillip to the industry 4.0. This kind of supply gluts can happen anytime soon. This is the lesson we have drawn in the last couple of years. And this is the time where we should think more about localization, and localization can happen through additive manufacturing. Scouting for greener technologies, I already talked about it, like why the government, the oil and gas companies have taken it very seriously, because the governments have proposed or placed different zero emission targets, that like UAE has pledged 2050 as its zero emission target. And to do that, the oil companies, particularly these oil-rich countries in the Middle East, they have taken this kind of initiatives very seriously. And recently, a report was published by Protolabs, and it says that 83% of the oil and gas companies are actually interested in taking up different 3D printing or additive manufacturing solutions, just because they are seeing the benefit in streamlining their supply chains. And this is given a new concept of manufacturing as a service, which can be called MAS. In the similar terms of SaaS, which is software as a service. Now, any concept of this manufacturing as a service is coming up. So this is expected to cut cost and reduce emission, and as well as expedite the green energy transition. This is very important from the point of view of additive manufacturing. So I'll now talk about the challenges ahead. What is actually still we see, even if we see a lot of developments happening in the United States and Europe, and also India, we have seen a lot of developments towards towards additive manufacturing technologies adoption in oil and gas industry has happened. We haven't seen quite that much of traction here so far in the Middle East region. There are few pain points there, which probably we'll have to address very quickly. What will be the solutions that we'll be providing for corrosion protection? If they're investing in something of a new technology, then the industry should find in this corrosion problem should be taken care of either through very high grade material or metal, or if it's polymer, then which is polymer gives a better chance to fight corrosion. So if it can also solve along with its other applications, if it can also solve the problem of corrosion, that's a big brownie point for the industry. Proven durability under high temperature and pressure. The pressure and temperature are very very important aspects of any process-driven industry, and oil and gas is no difference. And particularly in this region where the temperature can soar, the environmental temperature can soar up to beyond 50, then the importance of high temperature resistance is most important. One of my experience previously was like, if we use linear low density polyethylene, it starts softening at different temperatures, means various temperatures going beyond 50 degree. But the moment the other high grade temperatures like PTF and others come, then the stability comes in. So this kind of applicable, while we think about bringing polymer into additive manufacturing for oil and gas industry, we should think about this point also. Weight reduction, it's more important in the aviation, but also a lot of application can be thought out in while we'll be newly designing new devices and equipments for additive manufacturing. Then this factor should also be should be considered, the weight reduction point. Cost optimization. Overall, cost optimization has been discussed, and this has been a driving force. Means if we cannot reduce the cost, the project lifecycle cost cannot be optimized, then we'll probably will not see the economic viability of the new technologies. So this is another very important pain point for the industry. And then there'll be the most important part, which will be risk mitigation. Even if we have the technology ready with us, so we'll have to showcase to the industry people, the end use people who will be using it on field. If we cannot show them the how we are going to mitigate the risk, and if we cannot build the confidence in the minds, then they will not be successful. This is another point that we have noticed very recently while moving on different fields. We are particularly for material, that's a very big concern when it comes to whatever we are proposing the material, like if it's metal or even it's polymer. So we'll have to be very specific about how we are meeting the standards. So this is where the scope of the third-party assurance companies and agencies will come very strongly. Dr. Sastry is there; he will probably talk more about it. The process also is very important, how we are doing it. It's not just that we manufacture something, you say that it's innovative, it's green, something that will not add value to the whole process until unless we can, certify the process itself that this is the right process being maintained. And for that, the kind of the documentation and the kind of certification that will be required is very important. And on top of it, everything will be done by people. People should be trained, and people should be, the confidence should be built in their minds. So proper training will be required, and which is not there at this moment. We are trying to do it at different levels. We are we are recently, pre-qualified by NOC, and immediately after that, so we started taking up education is more important than, product selling. So we are trying to hold different workshops across the different platforms of NOC and others. Another point we have recently experienced is that OEMs design and innovation centers are not here in this region. They are mostly overseas. We see it in India, in the States, and in Europe. So what happens is that the design team, since they are not here, so they are not considering these aspects or the application, the end user point of views from this places. So if some OEMs happen to move this, move this innovation centers towards this region, that can have some values, which can be thought out in the coming days. And Another aspect is very important that we have recently seen the UAE government. Yesterday was a program for Make It in Emirates, and Aramco and US Saudi government is also holding different events for that to start to build a manufacturing culture, which was not there previously here. It was more into trading, and it happens is like that some of the oilfield services companies, they are already using additive manufacturing parts, but they are not disclosing in such a way, not disclosing, we say they're not explicitly marking it or promoting it as a 3D printed, because the culture here is not still built up. It is still in the making, and more work needs to be done in that segment. And training of workforce is most important. As we move towards this adoption of these technologies, once we have the technology and process in place, we should, simultaneously we should be training people. There are different certification courses should be developed, considering the workforce here. Language barriers should be thought out, and how we are going to address all this. I will now come to the the facility we have developed in Falcon Technologies. Quickly talk about it, and it's a government Ras Al Khaimah initiative there, and it's part of. Okay, yeah. It's a government of Ras Al Khaimah initiative, and we are based in Ras Al Khaimah. Now we are working out of that, but we are also have different kind of representative across the Emirates and also in Saudi. We have recently been pre-qualified by ADNOC and also DP World, so to conduct digitalization and 3D printing drives. And we are supporting these initiatives, Make It in Emirates, and I see this kind of profile. We from our previous, since this company has been here in the Emirates of Ras Al Khaimah since 2004, and we have offices across the globe. These are our core solutions that we provide. Starting from that, we try to make it end to end, when from the concept to the product level, or even post-product training, etc. We start from laser scanning and reverse engineering, and also design for additive manufacturing services. Then definitely there is polymer metal 3D printing. And there is functional prototyping and product development processes also conducted. We regularly. I think Harsh, yeah, okay, fine. Thank you, Harsh. Okay, so coming back to our solutions, functional prototyping and product development. Starting, we are helping different kind of injection molding companies here for their kind of dies and development and etc. Then cross-training of workforce is another solution we provide, because many times many companies here, companies and the kind of government agencies are having the machines, the printers here, but they are not aware how to go ahead with the printing process, or how to incorporate the whole additive manufacturing process in their design thinking. And post-processing is obviously there. It's a part of the whole, the product development and kind of solution, and validation, testing, and certification with other bodies, third-party agencies we are conducting. And I would like to show our machines, the polymer machines particularly. We have two machines. One is EOS SLS machine. The bed size can be seen as 340 by 340 600 mm, which is quite a good size, I believe, in the industry. And we have one HP multi-jet fusion machine. This is of medium size, and both are quite capable of their good work. This is the exact facility. Our facility is a class 7 clean room, totally dust free and etc. And we have been doing it everything in house, and from the printing to post processing. You can see in the picture here. And yeah, this is from my side, and thank you for this opportunity. I'm open for questions. Thank you.
Yeah, hi Tirtha. We'll take up the questions perhaps at the end, because we need to move on to the next session. Sure. So maybe if any of the audiences have questions, please, for Tirtha, please reserve them for the end. So with this, I'd like to invite Kyle Mason to share his insights on case studies. And thank you, Tirtha, for setting that foundation in terms of what opportunities are there and why AM can play a role. So thanks for that. And with that, Kyle, good to go.
Thank you, Aditya.
Thank you, Aditya. Yeah, just a quick introduction to myself. Again, my name is Kyle Mason. I am the territory sales manager for Markforged, a 3D printing OEM based out of the US. So I'm the manager for the Middle East. So I've been working with a lot of clients in the region, specifically in oil and gas, helping to address and solve their problems and figure out how do they implement 3D printing? How do they find the right solutions for them, and how do they address the key problems that are preventing them from scaling and growing their solutions and products? So what I'll talk to today is just a little bit about customer stories, who's using it, why they're using it, what value they're pulling out of additive solutions, specifically in plastics. And just before we get into those, I'll provide a little background on Markforged so that we have a little bit of context on how they're using our solution specifically to address a lot of the problems that they're facing in the market today. So talking about AM solutions, there is just quickly as a background to what we do, there's a lot of technology out there. Additive has grown vastly over the last decade or two. And there's been a lot of different technologies, variations of each that have come into play. Where we fit in as a technology is within the extrusion side of things. So fused filament fabrication is the core foundation of our technology, basically extruding material layer by layer to create a three-dimensional part. That's the simple terms for it. So when you look at Markforged, we're the creators of the digital forge. That's kind of our fancy term for identifying our entire solution. So we make printers, we manufacture our own materials built specifically for those printers. And we also have a cloud-based solution for software that helps to manage your print farm, slice your parts, prepare them for the printing process, review analytics, and control your entire fleet. So all these items are kind of controlled and built seamlessly together to have a single user experience when you're talking about the full solution of additive manufacturing. It's not just printers. There's multiple different facets that are important when looking at addressing an entire system or a solution and implementing that into a process. So with Markforged, we have roughly about 14 plus distinctive materials, different plastics, composites, continuous fibers, as well as metals. So in addition to doing polymers and continuous fibers, Markforged is heavily focused on the metal side of 3D printing. Obviously, today we'll focus on the polymer side. We have 3 core software programs when it comes to slicing, print management, part evaluation, and part validation. Those are primarily all cloud-based solutions, so that way they can be accessed and leveraged from any point in the world. Obviously, today's focus is looking at printing at the point of need, being responsive and consolidating that supply chain so you're printing locally. So having those programs built to scale globally, where you can be printing in the US and have your systems and set up in a completely different country, really allows you to leverage the technology from any point in the world. And then lastly, 8 different printers. So again, we've scaled our systems to be anywhere from the low end in terms of entry-level printers to large format industrial 3D printers. So when we talk about hardware kind of as the core foundation of additive manufacturing, it's important. We need systems built for the factory floor, for the field. And that's what Markforged really focuses on delivering. And we do that across a wide range of different sizes, platforms, capabilities. Predominantly, we started in the thermoplastics and continuous fiber. When we talk about continuous fiber and composites, that's essentially what we are doing with our plastics, is reinforcing a thermoplastic with a strand of continuous composite material. And we'll talk about those composite materials. But those were our focus in kind of the small to medium range. And then recently we upgraded more to a larger format system that can produce the same quality of parts on a bigger solution, delivering the same type of precision and quality, but also addressing other areas like high temperature thermoplastics, as Tirtha had mentioned before, like Ultem and Peak. And you can just give a good indication of kind of that size comparison with those parts. So looking at size, opening up that range of products and capabilities, and taking what we excelled on with our smaller production systems into a much different level. So when we look at materials, Markforged manufactures majority of their own materials. We extrude all of our own filaments, and we do that across a wide range of polymers that help to bring different certifications, different types of characteristics that you might be looking for in an industrial environment. Our base product that we manufacture is Onyx. Onyx is a chopped fiber material. So it's nylon based with microfiber strands to help give it more industrial strength. And Onyx has different variations of its form. Onyx FR for aerospace. So that FR stands for flame retardant. So self-extinguishing material for safety requirements that might be more stringent. You know, you could be a final end use part on a plane where you need that application in order to have that flight ready. And then you also have things like Onyx ESD, which is an ESD safe material. So static dissipating. So making sure that you're not damaging electronic systems by having the buildup of static and burning out those systems. So variations of this core material has really helped us to expand our range with who we work with. And then we've also expanded that into different ranges of prototyping materials as well as end-use products like Ultem. So Precise PLA is our newest addition to the thermoplastic range for low-cost prototyping before you might be going to Onyx or to an Ultem part. Ultem 9085, obviously with our FX20, the high-temperature printer, that's a newest material that we've introduced to the Markforged platform to really address high corrosion, high temperature applications, and also address more niche areas where this material is already certified. And you can see kind of the range of that strength. Comparing it to traditional plastics, the industrial Onyx material really helps to take those basic conventional filaments up to a next level and apply them in a more factory environment. But what really changes the game is continuous fiber. And as I mentioned before, we reinforce our parts with this internal strand. So the best way to compare it is concrete and rebar. Concrete's your thermoplastic, rebar is your continuous fiber. And so this allows us to achieve a much higher bandwidth of strength. Now you take a part that's just thermoplastic with maybe a little bit of flex, a little bit of strength to it, and increases it to be comparable to an aluminum 6061 in many cases. So when we look at industrial environments and having aluminum be one of the most common material used out there for manufacturing parts, this opens up the doors for wide ranges of applications where you can leverage the benefits of additive and apply them directly to end-use components, tooling devices in a factory or in-field environment. And when we look at capturing value out of these different materials, you can see this nice little diagram, this hexagon. There are different areas where different materials excel. Some might have better print quality and strength. Others might have better heat resistance and chemical resistance. So when you look at trying to capture the most value out of a system, you can look at these different characteristics and try to hone in the either each material built for those specific applications or one that caters towards a lot of it. And in most cases, Markforged has used the objective as less is more. You know, one material that's really, really good for a lot of these applications keeps things simple, concise, and allows you to apply it in many different forms. So today, all these areas where you see stars is where Markforged is really focused on. Mostly with the nylon and continuous fiber, those are more the same. You have the base Onyx material with the different ranges of continuous fiber to help cater towards various strength characteristics. And those continuous fibers can range anywhere from a Kevlar for good impact resistance to a high strength, high temp glass material for high heat deflection. So you have these different materials to really cater the mechanical characteristics to whatever the end use application for is. And then obviously the most recent addition with Ultem, looking really at chemical resistance and heat resistance, which is impeccable or extremely important for the oil and gas industry when looking at high pressure systems, in-field use, oil, exposure to different chemicals and fluids. Obviously, that's a really, really important material. So capturing value across a wide range is obviously really critical here. And then looking at various forms of why these materials excel in their different regions. Unmatched surface quality and accuracy. We want our parts to look good. That's obviously important when looking at end-use components. And we need them to perform in a way that they can be integrated quickly with limited post-processing. Having parts that are super accurate and limit those post-processing steps is important when integrating this into a workflow. High chemical and heat tolerance. Markforged has been known for just having really, really robust parts. Many of our materials have ranges from 50 degrees Celsius all the way up to 175 for heat deflection. So opening up that range for more heat demanding applications, as well as being exposed to a wide range of chemicals and fluids and being able to withstand those. A lot of our applications are in tooling devices. Being exposed to harsh cutting fluids that eat away at generic plastics has limited a lot of the conventional filaments out there to be mostly focused in prototyping. So opening up those doors from that perspective is obviously critical for this industry. And then build tough. Strength is one of the biggest barriers with 3D printing, and the introduction of continuous fiber has been probably the biggest game changer in the last 10 years when it comes to using parts in an end-use fashion. So some examples, we actually have a customer called Wärtsilä, which is an industrial boat manufacturer, they actually have a tool that they use at a thermoplastic continuous fiber that is rated to lift 240 kilograms, an engine piston, and with a factor of safety of 4. So it's cleared to lift 240 kilograms, but it actually can lift over 1,000 kilograms given that factor of safety. So these are the application spaces that we're looking for. And the combination of these 3 different features, unmatched quality and accuracy, robust in environment, as well as high strength, obviously create a really end-to-end solution for in-field use and applications. So let's take a look at a couple of different cases here and these real-life customers today that are utilizing Markforged and additive manufacturing. So Siemens Gas and Power is one of our largest customers. They have a number of printers globally at this point, and they're leveraging, obviously, this predominantly from tooling and fixturing, which you can see today. So for maintenance. When things go down, when parts fail and they need to do in the field maintenance, that often means shutting down facilities, limiting production, and that can make huge impacts to the efficiency of the plant, the cost of having that plant be down, and it's obviously a non-desirable in many cases. So the alternative to looking at sourcing parts locally or bringing those various parts back to their facility to do repair was their main problem. So looking at alternatives to address that in the field was mission critical. In this case, what they did was they bought about 7 Markforged X7 printers. It was that middle of the range printer that we saw before, and they started doing R&D on various types of in-field tools. These were just from a prototyping standpoint. So they were producing these tools, doing iterations, figuring out how they can get these tools in the field. And they often did in-field testing with the 3D printed components. And they often found that the 3D printed composite components were so strong that they were able to actually forgo manufacturing these in aluminum and conventional metals or machining them out of industrial plastics and actually 3D print their end user tool. So the picture that we're looking at here is a great example of their turbine chasing saw. So this was a tool that they were prototyping, realized that it was industrial enough and high strength enough to be used in the field by technicians to do maintenance versus bringing those end user parts back to the facility. And they were able to leverage that and iterate on this tool multiple times to get to make it more lightweight, more ergonomic, and overall have a better tool that met their quality, met their standards. So obviously the key benefits that they got out of this was a high strength composite that was great for end use applications, surface quality that can be applied in other areas where they wanted to utilize these in various plants, and speed of process. Having control of those printers in their facilities was the biggest part here. Rather than sourcing parts externally, relying on somebody else to do the work, they were able to control this process, determine their schedules, and be more flexible and dynamic and responsive when it comes to servicing parts in the field. And the results were pretty apparent. 90% average reduction in lead times is a massive decrease when manufacturing these types of tools. So another case here, this was a Canadian oil field service company. So they help out larger companies to do the various types of services. And what these guys were primarily focused on was reinforcing piping with a different type of reinforcement tape. So they're doing a lot of servicing and maintenance and manufacturing for a lot of these major oil field companies in Canada. And their biggest problem was obviously customized parts. Same situation as Siemens, outsourcing these, relying on third-party vendors to produce parts and supply them was obviously a huge barrier and extremely costly. Manufacturing aluminum parts from third parties can be a massive undertaking from a financial perspective. So they were really looking for ways to optimize this process and increase the efficiency of their production line. So what they looked at was manufacturing various types of custom spare parts around their facility. Things that they would typically that would fail, and they'd have to put in that request. They could easily print those in-house, replace them, and the iteration speed was the most critical here. So being able to print around the clock, we always call that lights out manufacturing. They could start a print on a Friday and come back Monday morning and have that ready to go versus putting in that request to a third party, waiting another couple of days, then going through that manufacturing process and being docked by massive costs. So the results were very apparent here. 45% of their parts were reinforced with continuous fiber. They had 53 different unique 3D printed parts that were used to help with their this manufacturing process, and they had saved 27,000 Canadian dollars in a very, very short amount of time. This is off a $25,000 printer. So the magnitude in that ROI was almost immediate when bringing this solution in-house versus relying on third party. And then this is a little bit of a different case here in terms of the scope. Vestas, I'm sure many of you are aware of them, but looking on the other side of the spectrum, outside of oil and gas, kind of what the competitors are doing from an alternative energy standpoint. Vestas being in the energy business, obviously very, very focused on green energy, looking to continue to reduce the waste with conventional manufacturing, as well as bring in consistency and leverage the benefits of additive manufacturing. So they took additive and were deploying a global project. So they were really looking to partner with an OEM that met a number of different requirements. They then identified Markforged as a prime candidate when it came to partnering with a 3D printing OEM, and that was for a number of reasons. But their biggest problem was consistency across the board. When looking at a supply chain, manufacturing can be very, very inconsistent. If you have plants in Sweden and Denmark and the US and India and the Middle East, you might be sourcing parts from dozens and dozens and dozens of different suppliers. So when you manufacture one part in one part of the world, another component in another part of the world, the consistency of those parts might vary. You might not be able to uphold the same tolerance, and those parts might be incorrect, and you might need to send those back to those suppliers. So the really core here with Vestas was getting consistency at a global scale. So when they looked at this, they identified this program called Direct Digital Manufacturing, and they partnered with Markforged to be their core partner in building this foundation of additive. And there were three primary, characteristics that they were looking for. One, part validation. Two, global control, having a decentralized or centralized network of 3D printers that they can access and control on a global scale. And then material options. So when we look at part validation, figuring out what you get from the printer. When you machine a part, you have no idea what you get out of that machine until you scan it, until you review it after the fact. We've created a software called Blacksmith, which consolidates that process into one process, one step. So as you print your part, it scans the part, every single layer, and it gives you cloud point data to tell you exactly how accurate your part is, whether it is or is not in the tolerance that you have spec'd out in your design. So Blacksmith allows you to print your part and immediately have a report of how accurate that report is. So going back to their problem of inconsistency from suppliers, they were able to consolidate this step, validate that their parts are actually what they produced, and then be able to deploy them in the field. And these parts were primarily inspection gauges. When they were going to install wind turbines, do maintenance, they needed these inspection gauges in order to make sure everything was assembling in the proper way and in a very consistent way. This helps save time during maintenance and manufacturing or in installation. And obviously, it creates efficiencies that they didn't have before. With Eiger Fleet is one of the core programs that we work with today. This introduces an enterprise level of fleet management. And when I say fleet, it usually means more than one printer. It could be 5, it could be 100 deployed kind of globally. So Vestas has roughly a dozen plus printers deployed globally, some in Denmark, some in the US, in other regions of the world. And what they were looking for to do was have control over these printers in a manufactured way. So being able to have tools like role-based access allows people to deploy them into various regions and create a governance. So if you're a technician, all you could do is access the printer and do maintenance and kick off prints. Maybe you're a designer and you just want to be able to design in the software and not to be able to start prints. You don't want to have that creative control. So you can create that different type of government and access based on what type of role you are, what team you are. Maybe if you're a secure project and you only want certain people to view that project, this creates a lot of various tiers that you can help to manage your fleet when it's deployed on a global nature. Then material options, high strength continuous carbon fiber. There's no other materials that can compete on that at a level and investment cost with what Markforged is doing today. As well as they're looking at copper as a potential solution in other ways. But today's focused on polymers. So the key result here from Vestas in this case, with their dozens of printers deployed globally, was cost savings per application, able to reduce the cost of each inspection gauge that they're manufacturing, reducing the time it takes. That second step of inspecting your parts could have a lead time of 3 weeks after manufacturing, just to find out that the part was wrong. So consolidating that time really brought these parts to market faster, and then validated performance. They knew what they were getting, and they were putting in the field in a consistent way. So if they produced a part in Sweden and they produced that same part in the US, they know they were getting the exact same component off the same solution without having that variance that we talked about before. So Vestas is continuing to do this on a global scale, investing more technology and figuring out ways to optimize and automate their manufacturing through software and through a single OEM. So all in all, democratize manufacturing. So that giving the power to where it is. If you're localized somewhere else in one area and another printers in another area, you give the power of the freedom to the technicians and the users to be able to leverage parts and print them at the point of need and be responsive and dynamic. So these are a couple of quotes from the Vestas team and why they really move forward with this additive program and selected Markforged in these various cases. So that is my quick presentation. We'll hand it off back to Aditya to introduce the panel and go through a couple questions.
Yeah, thank you, Kyle. Thanks for taking us through the technology overview and a few applications for the audience to take a look at what's been done so far and the potential. So we move on to the panel for today, where Dr. Sastry Kandukuri joins us, who's an overall lead at additive manufacturing at DNV, and he works on a lot of projects here and has seen the oil and gas industry adopting this technology. So welcome, Dr. Sastry, and great to have you, Kyle and Tirtha, in this panel as well. So before we have a few audience questions as well, but before we go to that, I had a couple of questions which I wanted to ask the panel and about a few of the sessions which were there and a few other happenings today in the industry. So my first question to Kyle, because he's spoken about the technology and various applications. So what aspects of implementing 3D printing are most critical when getting started? Because that's important to understand before we move on to the applications.
Yeah, that's a great question. You could buy the most expensive, best technology in the world, but if you don't have the right people and the right process, that'll fail. So it's really important to build the backbone of who's going to be operating these 3D printers and how they'll be used. So when it comes to people, having access to education and training is mission critical. Often when you have new technology come into play and people fail very, very early, and often in early stage phase of implementing new technology, the adoption curve becomes much, much less. They often don't use the technology as frequently, and they often reject it. So it's important to have a process and a plan in place for education, learning manufacturing, learning how to maintain the systems, learning how to leverage them and get the most value out of them. Having that access to education immediately at the point of implementing that new technology is absolutely mission critical. And then training, having people locally that you can rely on and to provide support is super important. So that way you can build confidence and excel with the technology early and continue to grow past that phase. Process is really, really important. You need to have a plan, and you need to have a plan to scale. Often what people make the mistake on, I think in many cases, is they buy a lot of technologies and they don't have a lot of plan for it. So they buy on short-term needs versus looking at long-term goals. So having that plan in place is really important, and looking at who you partner with and how you scale technology is really important. That goes beyond printers. Software is a mission critical aspect of the 3D printing process that people often overlook. How do you manage a print farm? How do you manage your part inventory, a repository of components? Those are mission critical. When you look at companies, if somebody does not have a software foundation that you can scale with on a global nature, you're already immediately capping yourself in terms of the potential that you have to build with that OEM. So you often make a lot of these investments, and yet they don't scale with how your companies look to grow it and capture the most value. So people and process are mission critical when looking at it.
Yeah, that's interesting. Anything to add, Dr. Sastry or Tirtha, to this specific question?
Yeah. I think, Kyle has very aptly put it, everything. The training and the transfer of the know-how to the actual end users who will be using it. That's the most critical, because without that, the push will not come. However, the decision makers and if it should not be is a kind of top-down approach. It should be bottom-up. Bottom-up is always easier to handle. When if we want to make some changes, and if it happens from the user side, that's the best solution. If they understand what they can use of this whole technology, then it becomes quite easy for them to think about it. Now the equipments are not designed for additive manufacturing. When we now go back to ADNOC and other work, and they do not have the most of the kind of the 3D files available. So what we are now doing is we have told them that first we will do digitalization for you. Once you are you have a kind of a digital library, then we'll go ahead with the printing part. So I think this is very important. Now they're understanding the whole process of digitalization, then asking that, okay, what to do with this file? Then we say we'll print it, and you can use it in that way. I think that's the one. Dr. Sastry also can share.
Thank you. But maybe you already both added a lot. But maybe I share a different perspective of training. Training is why, because in our standards also we demand that you should have a training program, and you should have a continuous monitoring. Yesterday I was in an audit at a facility, and we were telling them, most of our requirements, including training, is to protect the manufacturer. So first of all, they can see training or any other requirements into three types of, is it something, a bureaucratic thing that they are pushing? Why not anybody can print, or, why there should be training? And second thing is, why should I spend more money on something that is easily be done? And am I adding cost to the end user by, but of course, this industry is now more machine centric. You don't need really skills or anything too much. But so that's what you have to give your personal multi-diversified, opportunities to keep their interest. And of course, give the end users the confidence that consistently the part will come with the same quality. So everything is again pointing to training. So I would say, it should be a very important element here.
Yeah, that's great. That's great. I think so. Training is the main critical word, and as Kyle says, mission critical in terms of the application and adopting additive manufacturing. And moving on, I have one question to Tirtha, but before that, I'll just put in an audience question here, which was also addressed to Tirtha, and maybe other members can also join in. It's the question about high performance polymers, and it's Rasha who is asking the question, and what's the highest achievable temperature that these polymers can work with in these applications is the question. So Tirtha, if you want to add in, and maybe Kyle can also chime into that.
No, I have I have experienced that peak and carbon peak is giving quite a high temperature showing. I think peak around 250 degrees kind of tested temperature, and carbon peak is around 280 degrees centigrades. So this is pretty high. And Kyle can, I think, add more onto that if he has some information on that.
Yeah. I mean, in terms of Markforged, which I'm more familiar with, our temperature range is anywhere from 50 degrees to about 175 degrees Celsius. With different materials, onyx being our base plastic that we typically work with, that's around 145 degrees C, and that's without the demand for a temperature controlled environment in the 3D printer. So when we're talking about easy, accessible plastic 3D printing on an FDM system, that's a really great range. That 145C, it really opens up the potential for high heat demanding applications. And then obviously when you look at the FX20, our heated chamber solution, the Ultem 9085 is obviously continuing to expand on that with a 175 heat deflection temperature. So not a melting temperature, heat deflection. So good thing to differentiate that, meaning that you'll see a degradation of strength, but it's not going to be disintegrating or melting in your hand at that temperature. So it could surpass that to some extent for minutes or hours, depending on the conditions of loading.
Yeah. Okay. Yeah. Thanks. Rasha, I hope that answers your question for now. But if you have any if you need any more details on that, do reach out to us, and we can put you in touch with the panelists as well. So, Dr. Sastry, oil and gas is a very highly regulated industry, right? So, how can the AM industry, while we're seeing a lot of 3D printing and components, how can the AM industry provide safety and quality assurance through third-party certifications to the users? Because this is very critical for further adoption of additive manufacturing. So, what's your thoughts on this?
Yeah. So yeah, thank you very much. I think so. This is a bridge between the manufacturing industry and the end user industry. I mean, the certification and quality assurance. So when we work with both these segments isolated, so for example, if we talk to some of the manufacturers, they think they are equipped with best skills, best machines, and best technology. And they would wonder why I need to go through a thorough qualification or some kind of verification. So I'll cover that perspective. And when we talk to the end users, we are actually not only looking at that single part, but we are looking at giving assurance to their complete asset. It could be a platform, or it could be a subsea installation, or it could be any other. So there could be again thousands of components there. So we have actually a lot of insights that the consequences of end users. So this is very difficult to convey to manufacturers because manufacturers are just thinking at a part level. So okay, so how we are solving this issue, it's not only for additive manufacturing, but for any other parts, but most of our technologies, traditional manufacturing technologies, these are those manufacturers that have a kind of a ticket to the trade. They understand, they understand the requirements and the liabilities that can come. So the additive manufacturing sector is quite new. So while they are spending their energy in optimizing and improving things, it's very difficult for them to stretch their hand and understand the oil and gas. So certification saves their time, and that's how. Yes. So how this is simplified is end user industries and also the certification bodies like us, we have written standards that actually classify parts into, for example, three types like we call additive manufacturing category 1, 2, and 3. So 1 being the low critical parts, where I can refer to what Tirtha was presenting about the qualification of material, qualification of process, qualification of personnel. So when you have this and a kind of a quality management systems, you don't need to qualify each and every part if this is a low critical part. Same part, exactly same part could be one time that is used somewhere in a for example, take a handle of a valve. Yeah, it looks a very, very simple part, but that can be used for some kind of a tap or small water tap or somewhere, versus that actually be an emergency valve, and if it is, it is not functional when you need it in an emergency. And so yeah, function is very important of the application. So that's what they have to define, those things. What is the application as a additional requirement for manufacturing requirements? So MC1, MC2, and MC3, they are going to high temperature, high pressure. So we will not be forcing the manufacturers to do similar qualification for all these. So a lot of times our qualifications and certifications coordinated with end users are to help the manufacturing industry and supply chain industry to understand this simply and mitigate the risk. Again, I see Kyle and also Tirtha has mentioned about the risks. Risks could be, to simplify the risks, they can be three criticalities. One is you're using a part for some kind of low tech utility, as I said, some small normal operations. But if you have a operation critical, that a failure of a component can shut down your operation, that's a medium level. Whereas a failure of a component can be really threat to the whole asset and the safety of the personnel and people, and the environment. Then it is safety critical. So one has to understand those things. So if you are going for an automobile application, a failure of a small component maybe have a very little consequence compared to the huge consequence coming from the oil and gas. Yeah, so I would stop here, but what I wanted to say is certification, and we are trying our best. Yes.
No, that's great, and in this, on this background of what Dr. Sastry has told us about the risks and the standards needed. Tirtha, just want like to know, what are the hurdles perhaps what we are facing in adoption of polymer AM in oil and gas sector. Can you throw some light on this, and based on your background and understanding of the oil and gas in the region?
I would like to dissect it in two parts. One is adoption of non-metallics itself is a hurdle, and instead metal, which industry has been accustomed to using everything in metals for decades. Just switching quickly to a non-metal itself is a hurdle. Then on top of that, accepting additive manufacturing. To be frank, when I started using non-metallics couple of years back, then before that, probably if you count it like 5 years back, I would not have been convinced that non-metallics RTP and that kind of pipes can be sustainable kind of a solution. That is one aspect. And second aspect, probably till last year when I was just engaged in my previous industry, oil and gas only, if somebody would have told me that this can be, the additive manufacturing was not the common term, and 3D printing, I thought this was something fancy. And to be frank, this is the level of the same level that my other people are also there, old colleagues, because it's very obvious. Means this other the conventional ones and the metals has been in practice for decades. So we have to think, we have to wear their shoes, we have to put ourselves in their shoes, and then think about it. Means then we'll have to come about, think about, like, if we are going to we'll have to highlight the benefits first of the polymers of this one, the composites, polymers, overall non-metallics, that what non-metallics, how it's gonna be a benefit. If we say that it's the greener solution at the end use level, nobody is going to accept it, to be frank. We have to give them the user benefit, how their life will be easier while handling day-to-day tools. I'm just giving kind of, I used to be on the one end user, so I'm giving that perspective. So we'll have, that's why I'm saying that the bottom-up approach will be the best solution for this and best route. And then on top of that, we'll have to design, like, if we are using additive manufacturing, we should think about, now we should instill the design for this one additive manufacturing concept also. If you're using the same item, probably which is injection moldable, then we'll not have the right benefit tapped for it. We should think about how we can probably embed some sensors in it. If we can give them the end users this concepts or this design thinking process, then I think that will add some value to it. So I see this as two hurdles. First, as accepting non-metallics, then accepting additive manufacturing, these two processes.
Yeah, that's quite a interesting insight. It allows people to understand how this needs to be approached. Right, people who are looking to drive adoption, let's say, of additive manufacturing in the region. So, just taking another audience question in between this is, it's a question for Kyle. Uh, is fused from forming printed recommended to use as a functional part in wet applications? And does these parts have any issue with water absorption and swelling? And is it possible to achieve H7 machining tolerance on a material extrusion printed part?
Yeah, that's a great question. Obviously, a very, very loaded question. When it obviously depends on the material. When talking about applications that are going to be facing or be subjected to fluids, it depends on the conditions of those parts. Is it submerged for a long time? Is it a pressure body? Is it just being exposed to water? Splashed, whatever it might be. So those challenges are going to be highly dependent on that application space. What I can say is a lot of our materials are being used in a water-based environment. Parts that are in salt water constantly, that are exposed for long periods of time. This could be hours. We've actually worked with the U.S. military in some cases, designing full propulsion systems for water vehicles that have actually performed better than their aluminum counterparts. So there's a lot of different application ranges, but additional circumstances. The downside is that onyx is a nylon-based material. It will absorb water to some extent. So it just depends on, is this a pressure body? Does this need to be retaining water? Or does this need to be holding back air in a submerged environment? So those are all the conditions that you need and potentially test and look at post-processing to help achieve. But the short answer is, yeah, we've exposed our parts to water application and they work great in many cases. In terms of the tolerance, I'm not familiar with the H7 machining tolerance. What I can say is our printers and materials are highly conservative to be within a 150 micron tolerance. With Blacksmith, we've actually been able to scan a lot of our parts that have been printed and see that majority of the parts are within a plus or minus 50 micron tolerance. So that'll range on geometries and size of parts, but for an FDM process, it's highly consistent and very competitive with other these like SLS, where high precision parts are kind of what they're known for. So it's very, very competitive from that scope, and I don't think there are many printers out there from FDM that can compete in that.
Yeah, thanks for that answer, Kyle. Just we've shared a few insights now, and in recent publications or case stories or there have been applications where in oil and gas there are proven cases of 3D printing used for nozzles for various applications, subsea injection tools, off-road risers, and gas turbines. We've seen few of these applications at various levels. What does the panel think on the future in terms of other applications which could be taken up in the polymer applications in this space? So because there have been some proven applications, so there is a case for it. So what do you all think about this?
Maybe I can start
Kyle, sure.
From my perspective, low hanging fruit is best. Obviously, we've done a lot of R&D and development to identify and find those very mission critical components that are hard to manufacture, hard to source. But there's a lot of things that we brush over. I would say mostly in the tooling and spare part development or departments. Spare parts are mission critical for oil. Often have massive warehouses with thousands and thousands of parts that are constantly weighing down from a financial perspective on companies. So 3D printing really introduces a level to be dynamic and responsive. I've used those terms a lot in this presentation. So from a perspective of spare parts, bringing that spare part inventory to be physical to digital I think, a huge opportunity for companies to be a bit more flexible, free up cash, and not have to rely so much on having that physical inventory. So these could be small spare parts that are very simple. It could be electronic housing, or they obviously can move to a more complex nature of being, physical turbine blades in many cases, or manifolds. I would say the small spare parts that are easy to manufacture, something that aren't too complicated, that don't take tons of R&D to develop for 3D printing, as well as various types of tools that these could be maintenance tools that help to repair those parts in the field. I think that's a really key area to focus, because they're often much easier problems to solve, and that allows the industry to adopt the technology much more easily and then scale those much harder applications, like the complex manifolds or valve bodies or whatever they might be.
Yeah. I'd like to add probably, yeah, Kyle is up there, and probably we should also think about new designs coming up to the market, and based on the end user experiences, like probably the different jigs and fixtures can be a very apt market that we should think about, rather than just thinking about the big ones. Why don't we think about those ones which will be handy, which will be extremely customized, which will sometimes we should also think about the ergonomic point of view, means if that is also being if we think about polymers, so if it's giving some more value to the ergonomic point of view. And the another one can be the design for additive manufacturing with the concept of the DFM, that if we are embedding something, if it's a kind of heat prone thing, can we run some internal channels for coolants, something like that, so that it keeps the whole idea, whole item cooler than it used to be in the normal temperatures and etc. So these two things. So one is the extreme customization, I would say. Extreme might be the two on the right side, or like, so it will be kind of customization as per the individual customization, I would say, right wording. And the next is the design for AFM with the embedding and other kind of solutions can be the target markets.
So okay, so maybe I can again refer back to Tirtha. He was mentioning about corrosion, is one of the applications. So wherever there is corrosion and oil and gas is full, is around mostly offshore oil and gas is around seawater, and a number of opportunities, whether it is a chemical process equipment or piping or reactors. So there are a lot of equipment. But that is one is the corrosion application, where they have to go to metals or high performance metals, but there could be a technology qualification may be needed to replace it with the new polymers coming. That is one. And second one, also Tirtha mentioned about cost and weight benefits. For example, platforms that are outside, deep into the sea, depend on helicopters when they need parts. So our drones, whatever now. So every reducing a kilo, whatever, because they pay per kilo payload, then that is, if they are able to translate some of those parts that are otherwise made by metal into polymers, and that satisfy the requirements, that is one application. And also, we have been hearing that suppose one equipment was 26 kilos and you needed 2 people to handle it, whereas when somebody used additive manufacturing, it came to 18-19 kilo. 1 person is required, so you save a 1 person weight in the helicopter, and you need a lot of things. So weight reduction. And then third and most important is when you go to the deep into the water in the subsea applications. These days, general commonly made composites have a very many applications. They are replacing otherwise used by metals, like for example polymer chains, even though AM may not replace it, but just to say. So there are a lot of applications I would see for cost and weight reduction in the subsea applications. And the third one is again, if we refer to the same slide, high temperature and pressure applications. So there also, and while getting other benefits. So I would see a lot of benefits, but how to unlock is that's the main thing. And I believe as Tirtha was saying, again, design, collaborating with the original equipment manufacturers and reducing number of parts by clubbing them. Again, same happened with the metal. I believe there are large opportunities. So maybe I close with always what I say again, because I believe this is very important. A lot of people and companies think replacement of AM is one-to-one part, but then impact factor is one. If you see a gasket or if you see a small part or valve body, you replace it. Your impact factor is just one. But if you are providing a solution, like whether it is a tool or whether it is a functionality, your impact factor suddenly go to 20 to 40 to 50. When you actually, like also it was mentioned about additive manufacturing as a service. So anything let it come, and we are immediately helping you to bring up this equipment. We are taking the challenges. That is how the AM industry takes it as a manufacturing as a service provider. That gives peace of mind to the operators, and they can actually go more into their job and take more risks, and additive manufacturing can help them to take those risks. Yeah, this is where I can stop.
No, that's great. Thanks for summing up that, Dr. Sastry. And with that, I think we are also out of time for today. We have a couple of more audience questions, and we will share these with the panelists, and maybe they can get back to you with these. And thanks a lot for first of all to all our attendees who joined for this session on Polymer AM opportunities under the AM Chronicle Middle East Outreach session. And I'd also like to thank all our speakers, Kyle, Tirtha, and Dr. Sastry, for sharing their insights. And we look forward to bringing in more similar interesting sessions in the future, which are more focused on applications, and we continue to delve deeper into the potential. So thanks, everyone. And with this, we sign off for today.
Thank you.
Thank you.
Thank you all.
Thank you.
Bye-bye.
Bye-bye.
Bye-bye.